the last two clusters of first grade. We're covering measurement and data and then the geometry standards. So starting with measurement and data, students will need to measure lengths indirectly and by iterating length units, tell and write time, and represent and interpret data. Some common manipulatives, we're still going to use those non-standard measurement tools that we used in kindergarten. We need objects to measure, perhaps number cards, analog and digital clocks, whiteboards, markers, dollar bills, coins, anything that we can grasp our hands on. So from the shapes provided, order the squares from shortest to tallest. So I see I have an assortment of circles, rectangles, squares, triangles, and some of them are all shaped a little differently as they are turned on their side or rotated a little bit. So let's first start by identifying from the shapes provided, just grab the squares from that list. So I screenshot and took just the squares. And perhaps our intuition has already put them in order from shortest to tallest, but we can use snaps to put them together. So I just put a few snaps together using a virtual manipulative and then copied and pasted them into our PowerPoint here. So I think I have way too many, but you can see if we start from the shortest square that it's not even one snap tall. So if I compare that to the second one here, I see that it is slightly more than the yellow square. So it's going in order. If I move next to the green one is almost as tall as one snap. So it's definitely taller than the red one and most definitely taller than the yellow one. And then finally, if I compare the blue square, which is one full snap, that is more than the green snap or the green square, how tall the green square was compared to the snap. So we have put them in order. Continuing with measurement, let's say we have the following two sentence strips. How many bears long is each sentence strip? So I have the sentence strip, the cat could nap, and the dog sits on a rug. So I grabbed some of my bears from the virtual manipulatives and copied and pasted them here. And I see that it takes 3 bears to complete the cat can nap. And it looks like 4 bears to complete the dog sits on a rug. How long will the two different sentence strips be together if they are laid end to end? So if I were to take my bears and line them up, the sentence strips should be 1, 2, 3, 4, 5, 6, 7 bears long if I lay the sentence strips together end to end. And sure enough, they match. Let's write an equation to represent our work. So we see that we had 3 bears plus 4 bears equals 7 bears. Let's take a look at the ocean picture I have below. I'm going to use snap cubes to count how many of each that there are. So let's start with the shark. I look at my picture and I can identify that there are 1, 2, 3, 4 sharks. So I grab my counters, my snap cubes, and I put 4 by the sharks. Now let's move on to the dolphins. It looks like I have 1, 2, 3, 4, 5 dolphins. So I grabbed, 6 dolphins. 1, 2, 3, 4, 5, 6 dolphins. So I snapped together 6 cubes and I put them where the dolphins are. Next, let's look at the octopus. I see I have only 1 octopus in the top right corner. So I only need 1 snap cube. And then the crabs. On the bottom there, I see I have 1, 2, 3, 4 crabs. So grabbing 4 snap cubes together. And there are some wonderful questions that we can ask based on this data and looking and comparing our SNAP cubes. So which animal has the most? So students can count and we see that there are 6 dolphins, 6 SNAP cubes. So the dolphins have the most items in the picture. Which has the fewest? So the animal with the fewest is the octopus, since it only has 1 SNAP cube. Are there any animals that are the same? Well, if I line up my crab and my sharks here, kind of put them right next to each other, I see that they are the exact same. So the shark and the crabs have the same amount. How many total animals are there? Well, if I were to count all of my cubes or all of my animals in the picture, we'll see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 animals altogether. We can even extend this into more in-depth or higher level questions such as how many more dolphins than sharks are there? So if I put these right next to each other here, I see, based on things that we learned earlier in our first grade clusters, that there are 2 more dolphins than there are sharks. Some key words that are important in this lesson are the words at most, least, more than, less than, greater than, and equal to. So describing words. Moving on to geometry for first grade. There's just one main cluster here, reason with shapes and their attributes. So we need to distinguish between defining attributes versus non-defining attributes. Build and draw shapes to possess those defining attributes. Compose two-dimensional shapes or three-dimensional shapes to create a composite shapes and compose new shapes from the composite shape. And then partition circles, rectangles into 2 and 4 equal shares. Describe the shares using words halves and fourths and quarters, and use those phrases to describe them. Common manipulatives are 2 and 3-dimensional shapes, attribute blocks, pattern blocks, tangrams, geoboards, shapes, objects such as straws, gumdrops, marshmallows, popsicle sticks, etc. So I'm going to sort some following items and talk about them here. The baseball is a sphere. It is round like all spheres. I have an orange. An orange is a sphere because it's round like all spheres. However, it is the color orange, but not all spheres are orange. This food can here is a cylinder because it has circles on the top and the bottom. If I were to peel the label off and flatten it, the label is a rectangle. The toilet paper roll is also a cylinder since it has a circle on the top and the bottom. However, it is made of paper and not all cylinders are made of paper. The marker box is a rectangular prism because its corners are square, just like all rectangular prisms. A brick is a rectangular prism. It is really heavy, but not all rectangular prisms are heavy. The Egyptian pyramid is a pyramid because it comes to a point at the top. However, the food pyramid is not in the shape of a pyramid. It is flat, so it's not a real pyramid. Here are 4 triangles on the left. What do all of these triangles have in common? Take a moment to pause and review and look at the triangles on the left and look at those that are not triangles on the right and complete the sentence. All triangles blank, but only some triangles blank. Pause the video, write some ideas down, and come back. All triangles have 3 straight sides, but only some triangles are small. First graders are very literal, so think about that as I'm going through some of these. Another option, all triangles are closed, but only some triangles are upside down. The formal definition of a triangle is a closed shape with 3 straight sides that meet at 3 corners. It is not important for students to identify appropriate names such as a right triangle or a scalene or isosceles triangle. We're just identifying basic shapes. Here are 4 rectangles. What do all of these rectangles have in common? Take a moment, jot some ideas down, take a look at the rectangles and those that are not rectangles, and complete the sentence. All rectangles blank, but only some rectangles blank. Pause the video and jot some ideas down and see if we can match. All rectangles have 4 sides, but only some rectangles are red. Or, all rectangles have 4 corners, but only some rectangles are tall and skinny. The formal definition of a rectangle is that they are closed. Another fill in the blank, I'm sorry. All rectangles are closed, but only some rectangles are short. So the formal definition. A rectangle is a closed shape with 4 straight sides and 4 square corners. Here are 4 squares. What do all of these squares have in common? Take a moment to review the squares and those that are not squares and complete the sentence. Pause the video and come back when you've got them filled in. One option might be, all squares have 4 corners, but only some squares are blue. Again, literally, they will see a blue square and think that all of them could be blue. So identifying that only some are blue is important. All squares are closed, but only some squares are turned. A square is a closed shape with 4 straight sides and 4 square corners. The 4 sides are the same length. For this next activity, I want you to find a sheet of paper, just any old regular sheet of paper. How can you share the paper equally so that you and I get the same size piece? Think about that. Then fold your paper to show how you and I get the same size. Reflect a little bit. How do you know that you and I will have the same size? How are you sure of this? Reflect. Perhaps you folded your paper in one of these ways, diagonally, straight down the middle, known as some of you may have heard of the hamburger fold or the hot dog fold, top to bottom. No matter which way you folded, we notice that there are 2 equal parts. What can we call each part of our rectangle here? What part of our paper? Since each piece is one of 2 equal parts, or half the rectangle, we will call the shares halves. If you and 3 friends want to share a cake so that you each get the same amount, how much can each person have? Well, how many people are sharing the cake? So there's you and 3 friends. So that would mean there are 4 people sharing the cake. What does our picture represent? Here I have a circle here. What does this circle represent? It certainly could represent the cake. Knowing that a cake isn't always a circle. Sometimes a cake is in a rectangle, sometimes a cake is in a square. Partition the cake such that each person has the same amount. So we could cut down the middle, cut side to side, or it could look like this. It's a little rotated. Either way, we need to make sure that there are 4 equal parts, one for each person. What are these parts called? Since each piece is one of 4 equal parts, we will call these shares fourths.